Welcome to The Explainer. Today, we're going to dive into a pretty big breakthrough from Meta AI, something that could fundamentally change how artificial intelligence understands and even writes computer code. So, let's just start with a big question. We all know current AI models are getting shockingly good at generating code, right? But do they truly understand it? Do they have any idea what's actually going to happen when you run that code? And this, right here, is the heart of the problem. Most of these models learn from these massive, static libraries of code that's already been written. The cooking analogy is perfect. It's like memorizing every single recipe book on the planet, but you've never once stepped into a kitchen. You've never seen what happens when you actually mix flour and water, or what happens when you apply heat. They're missing the whole dynamic process of cause and effect. But Meta has just introduced a new model that takes a totally different path. So, let's get into what makes this so different. It's called the Code World Model, CWM for short. And yeah, it's a massive 32 billion parameter model. But believe it or not, the size isn't even the most interesting part. The real game changer is how it learns, which is by focusing on that direct link between an action and its outcome. At its core is this really powerful idea called a world model. You can think of it as an internal simulator. It's like a little mental sandbox where the AI can play out different scenarios. So before it actually commits to writing a line of code, it can run a quick simulation to predict what's going to happen. It's not just memorizing old moves, it's actually learning the rules of the game. Okay, so how does that actually work in the real world? How in the world do you teach an AI to build this kind of internal simulator for something as complex as code? Let's break down the process. And this just nails the difference, doesn't it? Traditional AI training is all about reading the finished recipe. CWM's whole approach is about being in the kitchen. You add an ingredient, you see what happens, and you learn from that direct, immediate feedback. It's that huge gap between just reading about something and actually doing it. So CWM learns inside what the researchers call Agentic Docker environments. Now that sounds fancy, but you can just think of them as totally safe, isolated little sandboxes. The AI takes an action, like running a piece of code, and then it just watches. It observes the direct consequence. And it does this over and over and over again millions of times until it builds this deep, intuitive understanding of how code actually behaves. And what's really cool about this is it gets to the core of the whole shift. The technical name for this is learning from observation action trajectories. But what that really means is that CWM can go way beyond just matching patterns. It's actually learning the why behind the code, not just the what. And that's what allows it to mentally simulate what's going to happen, step by step.
Okay, that all sounds fantastic in theory. But does this new training method actually make it perform any better? Well, the researchers put CWM through an absolute gauntlet of really difficult tests.
As the researchers say right here, the whole goal was to push past what was thought possible with the old methods. And, well, when they put CWM to the test, the results were pretty stunning.
On this benchmark, called SWE-bench Verified, which is famously hard because it uses real-world bug reports from GitHub, CWM hit a 65.8% pass rate. This means it can actually diagnose and fix really complex problems in existing software projects. That's a huge leap. And its talent isn't just for fixing code. On Math 500, which is a test for solving complex high school math problems, stuff that requires a lot of logical reasoning, it reaches an incredible 96.6% accuracy. And if you look across the board, the performance just holds up. What's so compelling here is the range of things it can do. From fixing very practical software bugs to tackling these super abstract, competitive programming challenges. It just shows a really flexible kind of reasoning ability, and it really proves the value of this whole training approach. So, the crucial thing to understand is that these incredible scores are really just one part of the story. The much bigger impact might be what this means for the entire AI research community. Meta has released CWM as an open weights model, and this is a huge deal. It means they aren't just publishing a paper with the results, they are giving the model itself, its entire digital brain to the world. It's a powerful test bed for researchers everywhere to poke at and build on top of. And they're actually going a step further. They're not just releasing the final, finished model, they're releasing checkpoints from each key stage of its training. This lets other researchers see exactly how it learns, from its very first training, through the fine-tuning phase, all the way to the final model. It's like they're sharing their entire lab notebook, not just the final result.
This kind of transparency, it's all about speeding up progress for everyone. It turns CWM from just another powerful tool into a foundational resource for the whole community. It's basically an open invitation to explore the future of AI that can actually reason and plan.
And that leaves us with the final, and I think the most exciting question. If an AI can genuinely understand the consequences of its actions before it ever takes them, what new frontiers in science, in engineering, in problem solving, what could we finally unlock? Definitely something to think about. Thanks for watching.